Awesome. Welcome back. Hi, everybody. Okay. For this segment, I want to start with a question. When your AI feature starts behaving differently, the output shifts and users start dropping, your confidence score goes low, it looks off. Who in your organization owns that problem? We're going to talk about it. Is it engineering? Is it ML? Is it data? Is it product? Who is it? So let's look into it and understand. If the honest answer is we would figure it out later, that's the problem this video is about. I have been in the rooms where something breaks and everyone assumes it belongs to someone else. And the PM thinks it's ML issue, ML thinks it's data issue, data thinks it's deployment configuration. And while everyone's pointing out at each other, users are quietly losing trust in your product. Most AI products don't fail loudly, they fail very quietly at a layer the PM did not realize they owned. Today, I'm walking you through a framework I use to map PM ownership across the three layers of AI stack: data, model, and deployment. Not at a theoretical level, but at the level of what specific decisions live where, what questions you need to be asking, what happens when nobody claims the boundary between layers. This is for PMs, tech leads, product teams who are building AI features and want to stop finding out about failures from user complaints. So let's get into it layer by layer. So first, we are going to talk about a little bit on why this layered view matters. The traditional PM model has clean boundaries. You own the features, you own the roadmap, you own the user experience, and engineering owns the code. The line is fuzzy at the edges, but mostly workable. AI breaks this model completely. Why? In traditional software, the code does what you wrote. In AI, the code is the model, and model is shaped by training data. Both of those are only useful if the deployment pipeline serves them reliably. Now, looking at this diagram, what you see here is three layers: data, model, and deployment. Each of these has decisions inside it that directly affect the user experience. Let's look at these. A PM focused only on the UX layer is operating on a third of the information. PM is seeing the outputs, but they are not seeing where those outputs come from. So here is a test I do. Think about the last time something unexpected happened in your AI feature. Not a bug in traditional sense, just the behavior changed. The outputs got worse and users started bypassing the feature. Response times went up. Now ask yourself, did you know where to look at first? Did you have enough visibility into the data and model layers to even start the diagnosis? If your answer is no, you already have an ownership gap. And that's not a technical problem, that's a product problem. The PM's job is not to be the most technically sophisticated person in every room, I would say. The PM's job is to ensure that nothing critical gets decided by default because nobody claimed it. That's what the layered view gives you, a map of where the decisions actually live. Okay, time to deep dive in these layers. So the first one is the data layer and the ownership. I'll say something that might be uncomfortable. Most AI product problems originate here, not at the model, not in the deployment, but at the data layer. Before the model was ever trained, a model that behaves strangely in production is very often behaving exactly as trained on data that did not represent the real world well enough. The model is not broken, the model is doing what it learned, and the problem is what it learned. So what does PM ownership looks like at this layer? Let's look at the slide. First, you own the labeling guidelines. This is the one that surprises people. Labeling is usually treated as one of the ops problem. Hire annotators, create tagging interfaces, run the pipeline, done. No, that's wrong. Labeling and guidelines encode product decisions. What counts as a correct output, how much ambiguity is acceptable, who resolve the edge cases, and when annotators disagree, So those are not ops questions. Those are actually product questions. And if the PM is not answering them, the ops team is by default taking it. Uh, the labeling guideline is the spec document of the AI world. If you have never written one or never reviewed one, that's a gap worth closing, I would say. Second, you define the inclusion and exclusion criteria. What data must be included, what data must be excluded, not for technical reasons. Your engineers can handle that. But for product reasons, what user segments need to be represented? What data would teach the model behaviors you explicitly don't want? This is a product decision and it needs a product owner. Third, you can identify systematic risks. Now, my litmus test for whether a PM generally owns the data layer, this is what I do. I would ask, can you name the 3 most likely ways your training data could be systematically wrong? And can you describe what would happen to the product if it were? So if you cannot answer that, you don't have enough visibility yet. Not the model might be slightly less accurate, but be specific. If our data overrepresents enterprise users, the model will fail on the SMB use cases, which is 40% of our user base. Example, that kind of answer, that level of specificity. Fourth, you align the quality gates. Work with your data team to make sure the automated checks are actually measuring things that impact user experience. Not just volume, not just format validity, distribution, coverage, recency. All of it tied back to what users need. The data layer is not engineering's problem to own alone. It's where PM defines what good means before a single training run happens. Now let's move to the next layer. Okay, layer 2, we are going to talk about the model layer. In this layer, this is where your product's core behavior gets shaped. What the model can do, how well it does it, what it declines, how it handles things it doesn't know. And here is the thing most people miss. These are not purely technical decisions. They are product decisions with technical implementations. Think about it. Now, capability scope is a product decision, right? Refusal policy is a product decision. The threshold for when the model says, I don't know, is a product decision. When the ML team makes these calls without PM input, you end up with a model that is technically correct, but product-wise wrong. It does what it was optimized or told to do. It just wasn't optimized for what the users actually need. So let's look at this. Owning the evaluation set and not just the evaluation scores. What it means. Most teams have evals. We call it AI evals, AI evaluation. We have our gates and ranges to evaluate the checks, true, false, everything. Automated tests, the confidence scores, the accuracy benchmarks, everything is included in evaluation. One question I always ask is, whose inputs are in this evaluation set? Was it built 18 months ago? Has the user behavior changed since then? Because a model that scores 94% on eval set might still be failing systematically on the specific inputs, your actual users send most often if those inputs are not in the evaluation set. Now, this is a PM call, not an engineering call. The eval set needs to reflect production reality. It needs to be refreshed as user behavior changes. And the PM is the person who owns what users actually do, which is what makes this their responsibility to push on. Let's look into defining the capability scope and refusal policy explicitly. What should the model decline, right? We need to define that portion. Okay. Handling I don't know gracefully is not an edge case. It is a UX feature. If the model hallucinates confidently when it's uncertain, that's not a model failure. It is missing a product benchmark or product requirement. You did not define what uncertain behavior should look like. Now, look at the decision thresholds here. When is the model good enough to ship? What is the minimum acceptable accuracy on your highest stakes use case? Did you define quality latency cost trade-off, or are you willing to make one? These feel like engineering questions. These are actually product questions. Without a PM position on them, the default is whatever the ML team is comfortable with, which may or may not be what users can accept. The model layer is where I have seen the most PM abdication, and it's usually framed as trusting the experts. Trusting the experts to implement is correct, but letting the experts define product behavior by default, now that's what I call a gap. Okay, now we are getting into the deployment layer. That is the third layer. This is where your AI product actually exists for users. It covers serving infrastructure, monitoring, rollout strategy, your error handling, your fallback design, and the UX of how model outputs are surfaced and framed. This is a very important layer. And it's a layer where PM ownership is most consistently underestimated. And why that matters, this is where product quality becomes observable, where latency directly shapes whether a user trusts the feature, or where error handling determines whether failure is a minor friction or a reason to stop using the product entirely. It's also where most incidents first becomes visible. And when the PM hasn't defined monitoring thresholds upfront, you learn about those incidents the worst possible way. User complaints. Now, let's look into the slide. Your rollout strategy is a product experiment. It's not a safety check. When you roll out to 5% of users, you are running a product test. What do you want to learn from the 5%? How will you know if the feature is working? What behavior in that cohort would cause you to pause the rollout? If you cannot answer these questions, the rollout is just an engineering precaution, and you're leaving an enormous amount of learning on the table. Define the learning goal before you run the experiment. Next one I see is setting the error budget as a product decision. How much degradation in a model behavior or availability is acceptable before you intervene? This sounds like an SRE conversation. It is actually a product conversation. Too lenient, the problem compounds silently until users notice. Too conservative, then your team burns engineering hours on incidents that don't actually matter to your users. The PM is the one who knows which failures are tolerable and which ones damage trust. Own that threshold. Yeah. The next one I see is designing the fallback explicitly. Why? It's important because what happens when the model is slow? What happens when it is uncertain? What does the user see when the feature cannot deliver? The failure state is part of your design. If it's under-designed, it will be bad by accident, and you don't want that. Looking into these layers, the next one comes to my mind is closing the feedback loop. This is one of the most themes leave on the table. When users override a model output, they skip it, they redo it, they ignore it. That is your signal. That is a product signal. Users are telling you the model got it wrong. If that signal is not being captured and fed back into your data layer, you are letting most valuable information in your product disappear. Yep. The deployment is not where the PM hands off. It's where the PM finds out if everything upstream was done right. Now let's go to the next step. This one is one of my favorites, and let's understand the integration map. What happens here is a cross-layer ownership to make these seams safe. We have covered all the three layers so far. Now I want to talk about the places that are more dangerous, vulnerable than any single layer, the boundaries. What happens is the seams between data and model, model and deployment, deployment and back to data. This is where the predictable failures live. The ones that look mysterious when they happen and obvious in the hindsight. Boundary one, data to model. Let's look at it. What happens here is the data shifts. User behavior changes. A collection process gets updated. A new user segment starts showing up. The model's behavior changed. And if nobody is watching both layers and connecting the dots, they surface as the model is acting weird. It takes weeks to diagnose because nobody looked at the data first. My rule, before I diagnose a model behavior change, I ask whether anything changed about that data in past 30 days. That single question itself has saved my team weeks of investigation more than once. Let's look into boundary two, model to deployment. A new model version ships. It's more accurate, but it's also 200 milliseconds slower on average, or the distribution of output length changed. Now the UX is cutting off content that used to fit. These are the product trade-offs and not engineering decisions that we need to look at. Looking at the entire process here, I need to be in the room when a new model version is being evaluated, not to make the ML call, but to make the product call about whether the trade-offs are acceptable. If I am handed the result after it ships, I'm too late. Boundary 3 here that you see is deployment back to data. This is the loop most teams never close. What users do with the model outputs in production is one of the richest data sources you have. They override, they retry, they abandon. Every one of those actions is a signal. If you're not capturing it, feeding it back to the data requirements, and using it to shape your next iteration or training cycle, you're flying blind. Closing this loop is one of the highest leverage things an AI PM can do. It's also one of the least commonly done, I must say. Let's get into the next set of details. Okay, let me give you a practical starting point today. This week, run a layer audit. For each of these 3 layers that we went through, data, model, deployment, answer 4 questions. 1, who is currently making the key decisions in this layer? 2, are those product decisions or engineering decisions? 3, is there a clear shared definition of good that team is working toward? 4, when something goes wrong in this layer, who finds out first and how? The gaps in your answers are the gaps in the ownership. And those gaps are exactly where the next preventable failure is building up quietly right now. So the layered view of PM responsibility is not the heavier job. It is the very honest one. It reflects what AI products actually are. 3 interconnected systems, each making decisions that affect what user experience. And PM's job is not to execute at each layer. It is to define what good looks like, to own the connections between these layers, and to ensure nothing critical is decided by default because nobody claimed it. So that's a full framework. 3 layers, 3 PM ownership models, 3 cross-layer boundaries where the most dangerous failures live. 2 things before you go. First, I wrote a full version of this article on Substack and LinkedIn. It has the complete ownership maps and deployment checklist and downloadable resources. Links are in the description. Second, this is part of an ongoing series of what AI product management actually looks like in practice, not from a textbook, not from courses, not from other videos, but from the teams that are doing it right now. So if you work in AI product and want frameworks that connect technical decisions to product outcomes, subscribe. I'm going to publish it regularly. Drop a comment if you have run into one of these boundary failures, data to model drift, deployment surprises, and the feedback loop that never got built. I read every comment, and best ones will get addressed in future video sections. See you in the next one.